It is 2026. Highly efficient humanoid robots have moved out of research labs and are actively punching the clock inside modern European logistics hubs and hospitals. Mapping out the architecture of these systems reveals a complex dual identity. On one side, the robot is a kinetic machine. Its high-torque actuators and rigid chassis pose risks of physical collision and harm, requiring strict machinery evaluation. On the other side, it is a mobile data processor. Its network of sensors continuously ingests environmental data, placing it squarely under rigid privacy laws. These identities overlap. If AI influences physical behavior, or a physical sensor collects identifiable data, the regulatory zones intersect. Successfully deploying autonomous systems in Fortress Europe requires solving this dual regulation burden simultaneously. The hardware cannot be legally placed on the market if the software stack violates digital governance, and vice versa. To prevent collisions with a pallet jack or a passing coworker, a humanoid requires a dense suite of perception tools. Cameras, microphones, and LiDAR constantly map the immediate surroundings. This continuous environmental mapping instantly triggers GDPR. Every face, every voice, every employee badge, and workstation behavioral pattern captured by those sensors becomes personal data under European law. Specific software functions elevate this risk further into what compliance teams call the biometric trap. Using gait analysis, emotion inference, or facial recognition upgrades standard telemetry into highly restricted special category data. Regulators require specific, documented technical fixes to mitigate these risks. Deployments must enforce strict data minimization, rely heavily on edge processing to keep data on the device, and apply active pseudonymization, like face blurring, before any telemetry leaves the robot's active memory. Baseline safety navigation must be technically constrained and legally documented, so it cannot accidentally evolve into illegal worker monitoring by way of a feature update. In many global markets, product safety, AI governance, and privacy obligations operate in distinct, fragmented silos. The European approach insists these obligations line up coherently. This integration sharpens completely with the EU machinery regulation, which becomes fully applicable in January 2027. This logic flow illustrates a critical shift. AI algorithms and software are explicitly classified as safety components, determining if a machine is legally safe. An over-the-air update altering obstacle avoidance instantly triggers physical machinery compliance obligations. The code changes the kinetic risk. Deployers must maintain constant human oversight, document transparent AI safeguards, and provide continuous, updated conformity evidence that proves the system remains safe after every modification. Treating a robot's software stack as an IT issue, separate from its kinetic certification, guarantees a market-blocking compliance failure. Placing a humanoid on the EU market requires a rigorous stack of technical documentation and certification evidence to prove the hardware is lawful. The foundational entry tickets include a central technical file detailing intended use, exact CE marking evidence, and AI-based safety component assessments. Manufacturers and deployers must retain exhaustive hazard identification and risk reduction analysis strictly aligned to EN ISO 12100 standards, covering everything from collision zones to battery thermal runaways. Theoretical product compliance is only the starting line. The evidence burden shifts significantly when evaluating actual workplace integration. Deployers must execute site-specific risk assessments. A robot navigating a closed, controlled testing lab carries a drastically different risk profile than the exact same model operating in a busy Flemish logistics center. Operational safeguards require deep documentation, task-based hazard analysis, defined pedestrian and charging zones, strict practical competency validation for the operators, and formalized reviews for any substantial modifications to the hardware. Pristine CE paperwork fails regulatory scrutiny if the operational integration evidence does not accurately map to the real-world deployment environment. Because the robot is a mobile sensor platform, a second, equally demanding sprint of digital paperwork is required to govern the data. Organizations must build a data mapping record that tracks every category of personal and technical data the robot captures, generates, infers, or transmits. Every individual data stream and processing purpose, whether it is safety navigation or user interaction, must have a defined and justified lawful basis under GDPR. A data protection impact assessment is mandatory. It is heavily scrutinized by regulators and must be actively updated whenever sensors or deployment locations change. Deployers must accurately map data flows, ensuring local device retention and deletion policies strictly align with broader cloud transmission rules. Connecting these robots to vendor SaaS environments requires formalized data processing agreements and thorough international transfer assessments if any telemetry leaves the European Economic Area. A deployment will be grounded if its physical capabilities are not matched by mathematically rigorous data control frameworks. Compliance for autonomous robotics is subject to rapid temporal decay. Hardware degrades, payloads change, and software updates continuously alter the system's operational behavior. This dictates a tactical schedule. Monthly and quarterly reviews must reconcile incident logs, evaluate altered floor layouts, and verify that automated data deletion rules are actually functioning. Strategic semi-annual and annual checks require formally revalidating physical safeguards like e-stops, auditing vendor updates to the AI logic, and revisiting record of processing activities entries. Managing this relentless tempo of hardware and software checks requires treating compliance as a dynamic, living operation rather than an annual binder exercise. Manual compliance creates an immediate failure point. Scattered spreadsheets, email threads, and local folders simply cannot track the rapidly shifting operational reality of an autonomous robot. The dual regulation burden demands continuous compliance, managed and tracked through a unified governance, risk, and compliance architecture. Automated systems proactively alert compliance teams the exact moment a privacy masking feature fails, or an over-the-air update alters safety-relevant logic, triggering immediate reevaluations. The productivity potential here is massive. Humanoid robots can effectively execute dull, dirty, and dangerous physical tasks, freeing human workers for higher-value operations. Brainframe Technologies provides the unified GRC platform necessary to bridge physical safety evidence, AI governance logic, and GDPR accountability inside a single, highly visible hub. To extract the full industrial value of humanoid robots in Fortress Europe, your compliance architecture must scale at the exact speed of your engineering.